Now what is memoryless channel? Yt is equal to x t minus 2. Okay, if you put here 0, you will get x minus 2. If you put here t is equal to 1, you will again get x 1 minus 2 means minus 1. Is there any relation between x minus 1 and x minus 2? No. It certainly changes its time. Again, take 2. It will be x0. So, in every time, every bunch of time, it changes its output. So, it is a memoryless system. Okay? You can now call it the system with a constant values are has memory and or have the previous values coming back again. It's known as memory system as memory, but memoryless system has different values, different inputs, different outputs. There will be no constants with each other. There is no past value again got into the fact. So that is memoryless system. So in that point, the point is that a memoryless system is not very flexible. Its current output value cannot rely on past or future value. Okay, that is the point. Past or future value, that's not dependent. I have shown you previously. I have put 0, you have a value. I have put 1, you have another value. I have put 2, you have another value. There's no relationship between outputs of the previous values that I have given to it. So it is memoryless system. Fourth point here, a system with input x and output y is said to be causal. Now this thing is causality. That is the memory and memoryless. This part has been discussed. Now the system of causality is causality. Think about these 3 points to understand this. A system with input x and output y is said to be causal if for every real t0 means the past value or the initial value, yt0 does not depend on xt. Yt0 does not depend on xt. ठीक है? So now a system with input x and output y is said to be causal if for every real t0, that means t0 means the previous value or the initial value, does not, yt0 means are the output of the previous, does not depend on xt, that means input, for some t is greater than t0. T0 means the positive times. Okay, listen it very carefully if you want to understand. Okay, t is greater than t0. T is greater than t0, the positive values. Here we know every positive value there is a time delay, and every negative value, if it's up from the 0, is time advance. If a signal is here, that is time advance. The signal is shifted to there, that is time delay. I have told you before with signals. Okay, so if you don't understand this, just go the previous lectures of this video to understand clearly that what is time advance and what is time delay. Very easy. Now a system with input x and output y is said to be causal. Why it will be causal and why it is not causal or anti-causal. Okay, the second point is, if the independent variable t, that is time, represents time, a system must be causal in order to be physically realizable. Okay, now I will show some system to be causal. Yt. Okay, x t x t minus 1 look onto it. That is the initial time, sorry, the current time, present time, and that is the time delay. Okay, if you put 0 here, that means y0, you want to place t is equal to 0, that will be x equal to 0, that will be x minus 1. Okay, now put y1 here, what do you get? x1 plus x0. Okay, the condition is that for every real t naught, yt naught does not depend on xt. Is there any value here that depends on this? Is there any value? Yes. If t is equal to 0, that means x equal to 0, y is equal to 0, and x minus 1 here. So if x is 1, x 0. There is certainly a value that comes again and again. If you take y2, look at carefully here, x2 and x2 minus 1 means 1. That means the past value that comes through again and again. The thing has a past. It is a causal signal and causal system. Okay, the past value is there. Now coming back to the another part, non-causal. To understand this clearly, non-causal systems can sometimes be useful in practice. However, since the independent variable need not always represent time. For example, in some situations, the independent variable might be represent position. That is very much the thing that they have told. We didn't understand this. Represent time might be represent position. Okay, I will give an example then to understand this. xt t plus 1, that is time advance, and in system that is known as future, that is present. Now put the value 0, x0 initial value, okay, x1, okay, so y0. Now putting the value 1, x1, x2, putting the value 2, x2, x3. In each of the value we can see there is certain previous value is there. Okay, so it is also a causal value, causal signal, causal system. Okay, and if it's just yt is equal to xt, different value, different systems from 0 to 0, that means does not depend on xt. I have told you before, does not depend on xt, but it depends. That is non-causal. If it is 1, that will be 1. If it is 2, that will be 2. Depends. Okay, so that is non-causal. Present, past, future.